Okay, so two more types of reactions we're going to talk about here, addition, and then we're also going to talk about a new type, substitution. So the addition we're talking about in particular today is actually adding in order to make an alcohol. You just learned about alcohols, now we're going to make them by addition. So just to review, that when I'm talking about addition, I'm adding something to an unsaturated hydrocarbon. So I have a double or a triple bond on the hydrocarbon, and I'm adding stuff to both carbons of that double or triple bond, and in the process the double or triple bond breaks. So here what I'm doing is I'm actually adding water to the double or triple bond, and one carbon gets an H from the water, and then the other carbon gets an OH, or a hydroxyl group, which ends up making an alcohol. Because the two things that are adding, the H and the OH, are two separate things, right? They're different. I end up having the option for getting isomers when I do this work, because I could get an H on one carbon and OH on the other, or vice versa, resulting in, depending on the structure, two different products. So an addition reaction can also occur when water is added to an unsaturated hydrocarbon to reduce the number of multiple bonds. So here's an example. If I have butene and I add water, okay, one carbon is going to get the H, the other carbon is going to get the hydroxyl group, the OH, and in the process the double bond breaks, and that ends up with butene-2-ol. Now, no matter how I add this, it will still be butene-2-ol, because if the OH instead added to this carbon and the H to this carbon, right, it would be the same exact thing, because now it would be OH here and H here, and then that would be carbon number 2 for the hydroxyl group. So it would end up with the same product. So I have to consider the fact that it actually could be more than one way, but at the end of the day, it ends up with just one possible name that I end up getting here. So that's an addition reaction, which means that we've now covered quite a few different types of addition reactions, right? So I've had addition where I'm adding H2, which is called hydrogenation. I've had addition where I've added, a halogen, let's call it X2 or HX, okay, where I'm adding either a halogen molecule like Cl2 or a hydrogen halide. We call this often halogenation. Okay, and then the other thing that I have is addition of water, H2O, in order to make an alcohol, right? I don't have a special name for that, but I make alcohol as a result. So that's kind of the three types of addition that we've covered so far. Now let's talk about a different thing entirely, which is substitution. So in substitution, what I'm doing is I'm doing exactly what it sounds like. I'm subbing something out. So a substitution reaction is one in which a hydrogen in a carbon-hydrogen bond is replaced with an atom or another group of atoms. So this is different than addition because I'm not adding, I'm instead replacing something with something else. This happens to saturated hydrocarbons or aromatics, benzene. Unlike addition, where it ended up happening to unsaturated hydrocarbons. So really different between these two types. So these reactions are quite a bit slower normally than an addition reaction when I have substitution. And that's actually kind of a way that we can tell whether something is saturated or unsaturated is by adding something like, let's say, chlorine or bromine is the better example, which is orange. And then based on how fast it reacts, we actually know if it's an unsaturated or a saturated hydrocarbon because the rate of reaction is very different between these two. So substitution, which happens with saturated hydrocarbons or aromatics, is slower than addition reactions. And it also normally needs like some lighter energy or heat in order to go forward. UV light is often used for this reaction in order for it to happen. So here's an example of a substitution. So if I have propane and bromine, and I react this, notice that this is a saturated hydrocarbon. I have a halogen it's reacting with. It will be either a halogen or a hydrogen halide, always for substitution. That's always what we're going to have. So what happens is that the hydrogen ends up being substituted with a halogen atom, right? So it could be any one of these hydrogens. Now, I end up with two different products here. I have two isomers because if I sub one of the end hydrogens out, then it's going to be one bromopropane. If I sub out one of these hydrogens here, then it would be two bromopropane that I end up getting. So I get one bromopropane, two bromopropanes, and then the remaining bromine that doesn't end up attaching to the hydrocarbon, and then the hydrogen that pops off makes another product of hydrogen bromide. So again, this is substitution, which means that something is getting subbed out from a saturated hydrocarbon like an alkane or else an aromatic. So it has benzene. Here's another example. Benzene plus chlorine gives me one chlorobenzene and hydrogen chloride. So benzene does not react by addition. It reacts instead by substitution. Slower reaction, needs that UV light or something in order for it to happen. But here a hydrogen ends up getting replaced by a chlorine. Now, any one of these hydrogens could get replaced, right? And ends up in the same product of one chlorobenzene and then hydrogen chloride. So we got to be really careful with isomers when it comes to substitution reactions to make sure that we get the correct products. So let's say, for example, we're going to put in a blank page here. Let's say we have something like, we're going to go with something that ends up getting a few different isomers possible. Okay, this is going to be a little bit crazy. Let's say we have this and we're reacting it with bromine. So first of all, interesting, because I could give you just these reactants, you have to figure out the type of reaction that's occurring. Interesting to note that because this is an alkane, so it's all single bonds, that this is going to react by substitution. So a bromine will replace one of these hydrogens. I have hydrogens here, hydrogens here, hydrogens here, hydrogens here. Now, a lot of these hydrogens are different, so I would end up getting lots of different possible products from this. So for example, if this bromine replaced one of these hydrogens, then I would end up with CH3, CH, CH3, CH2, CH2, and then a Br. Right, and then of course I have hydrogen bromide. I'm going to write that as one product because no matter what I would get hydrogen bromide. So that's one product I could get. So one of the hydrogens on this carbon was replaced by a bromine. I could also end up getting CH3, CH, CH3, CH. We're adding the bromine to this one now. I should say subbing. We're subbing the hydrogen with the bromine on this one now. So that's another product I could get, and HBr, but I already wrote that down here. I could end up subbing out the bromine with this hydrogen. So then I end up with CH3, C, bromine, CH3, CH2, and CH3. So now this hydrogen has been replaced by a bromine. Or finally, I could replace one of these hydrogens with a bromine. Now, it's important to realize that both of these are equivalent, right? No matter where I put the bromine, that's going to become carbon number 1 in this scenario. So let's go ahead and just kind of replace that one with the bromine and realize it's both the same. So CH2, Br, CH, got a CH3 here, CH2, and CH3. So I could have that product as well. I don't want to write out the names for this. That's going to be painful, but let's just name these on the fly so you would know what it would be called. This would be 1-bromo-3-methylbutane. This would be 2-bromo-3-methylbutane. This would be 2-bromo-2-methylbutane, and this would be 1-bromo-2-methylbutane. So 4 different names, which is how I know that it's 4 different isomers. So something as simple as this, when I'm doing substitution, ends up with a lot of different options of what I get for products. And again, like I actually would get all of these products. So if I did this reaction in real life, I would get all of these being produced in different quantities, but I would get all of them. So that is interesting to note as well, that all of these are produced in the process. Okay, so that is substitution. So far what you know in terms of different reactions is you know about addition. You can add hydrogens, you can add halogens, hydrogen halides, or you can add water to make alcohols. When I'm adding, it's to an unsaturated hydrocarbon. I can do substitution, where I'm substituting either with a halogen or a hydrogen halide, and then that happens to saturated or aromatic hydrocarbons. And then the last type that I know about is, of course, combustion, where I react with oxygen to make CO2 and H2O. Okay, that's it.